is a very interesting application of our area of a surface of revolution. Let's show that the surface area of a sphere is 4 pi times r squared. Okay, so what do we have to do? Well, the first thing that we have to do is figure out what's our graph of a function that we can rotate around that will produce a sphere. And so we think about this. Let's draw some axes here. If we take a half circle, a semicircle here, and rotate it about the x-axis, well, we're going to end up with a sphere. So this needs to be a circle of radius r. And so what's the formula for the graph of the function here? That's giving us this half circle of radius r. So this would be x squared plus y squared is equal to r squared. Or solving this for y in terms of x, is y is equal to square root of r squared minus x squared. Should be plus minus, but we want the positive root here. So this is the graph of the function that we're going to rotate. What's the bounds here? From minus r to plus r. And so we are going to, so now we have everything that we want to do, everything that we need to get things set up here. So going back to our formula, so we've got our f of x, that's the square root of r squared minus x squared. We need f prime of x. So that's f of x. So f prime of x is going to be 1/2 times r squared minus x squared to the minus 1/2 power. And then you have to multiply that by the derivative of, we're using a chain rule here, multiply by the derivative of what's on the inside times minus 2x. So this simplifies down to x divided by the square root of r squared minus x squared. Okay, what is under our square root? So let's think about, so 1 plus f prime of x squared. We don't just care about f prime of x, we want to square it and add 1 to it. So that's going to be 1 plus x over square root of r squared minus x squared squared. So it's 1 plus x squared over r squared minus x squared. Let's put everything over a common denominator, r squared minus x squared. And so we'll have r squared minus x squared plus x squared. And hey, take a look. Cancel, cancel. Our final answer here is going to be r squared over r squared minus x squared. Okay, so that's what's going to be under the square root in our problem. That's what's going to be under the square root in our problem. So once again, here's our formula. 2 pi times the integral from a to b of the function times the square root of 1 plus the derivative squared. So what's that going to be here? So we said our bounds are from minus r to plus r. And then for the function itself, that right here, that is going to be just that square root of r squared minus x squared. And then we're going to multiply that by the square root of what we just had in our previous slide here, r squared over r squared minus x squared. Okay, so we've got two square roots here. We can actually combine them together under a single square root. And hey, why is that a great thing? Cancel, cancel. And the square root of r squared is just r. So we are integrating r from minus r to plus r. And so this ends up very easily as 4 pi times r squared after you do a little bit of calculation. So hooray, we are able to derive that the surface area of a sphere is 4 pi r squared using this formula here for the area of a surface of revolution.